When images of Iran's Hormuz Island turning blood red after rainfall began circulating online, many viewers were shocked. Social media users quickly labeled the phenomenon as blood rain, sparking speculation, fear, and even conspiracy theories. However, while the visuals are dramatic and unsettling, the explanation behind this rare-looking event is entirely natural and scientifically fascinating. Hormuz Island, located in the Strait of Hormuz in southern Iran, is already known as one of the most geologically unique places on Earth. Often called the Rainbow Island, it contains over 70 different minerals, giving its mountains and soil a wide range of vivid colors. Among these minerals is iron oxide, commonly known as rust, which plays a central role in the so-called blood rain phenomenon. What actually happened after heavy rainfall? Parts of Hormuz Island appeared to bleed. Streams of red liquid flowed down hillsides and into the sea, staining beaches and coastal waters deep crimson. To the untrained eye, it looked unnatural, almost apocalyptic, but the rain itself was not red. Instead, the water mixed with the island's iron-rich soil, dissolving fine red mineral particles and carrying them downhill. This process creates the illusion that the land is bleeding, when in reality, the rain is simply acting as a vehicle for minerals already present in the ground. The effect is especially striking on Hormuz Island because of the unusually high concentration of red ochre and hematite in its soil. Why Hormuz Island is so unique? Hormuz Island sits on a massive salt dome formed millions of years ago due to tectonic activity. Over time, volcanic and sedimentary processes deposited a wide range of minerals on the island. Iron oxide is one of the most dominant, given the land its signature red appearance even in dry conditions. When rain falls on such terrain, erosion happens quickly. Fine mineral dust dissolves into runoff water, intensifying the red color because the island has little vegetation to absorb rainfall. Water flows freely across the surface, making the color change highly visible and dramatic. Is this the same as blood rain? Historically, blood rain has been reported in many parts of the world, often before modern science could explain it. In most cases, these events were caused by dust storms carrying red sand or clay particles over long distances, which then mixed with rainwater. The phenomenon on Hormuz Island is slightly different. The source of the red color is local soil rather than airborne dust. So while the term blood rain is catchy and emotionally powerful, it is scientifically inaccurate in this case. No blood, chemicals, or pollutants are involved. Cultural and social reactions? Despite scientific explanations, the images triggered strong emotional responses. Some interpreted the red rain as a divine sign or a warning, while others linked it to political tensions in the region. This reaction highlights a recurring pattern. When natural phenomena look extreme, they are often framed through fear, symbolism, or ideology rather than evidence. This doesn't mean such reactions are irrational. Humans are wired to seek meaning in unusual events. However, when emotional interpretations spread faster than facts, especially on social media, they can overshadow reality and fuel unnecessary panic. Environmental impact. From an environmental perspective, the phenomenon is not dangerous. Iron oxide is a natural compound and is not toxic in the quantities present on Hormuz Island. In fact, the red soil, locally known as geological, has been traditionally used by residents in cooking, cosmetics, and even art. However, increased tourism driven by viral images raises concerns. Large numbers of visitors walking on fragile mineral surfaces can accelerate erosion and damage. The island's unique geological formations. Ironically, The same phenomenon, attracting global attention, could contribute to its degradation if not managed responsibly. Lessons from the blood rain, the Hormuz Island. Event is a reminder of how easily natural science can be misunderstood when visuals overpower context. It also shows the importance of geological literacy. Without it, extraordinary but harmless phenomena can be framed as omens, disasters, or mysteries when they are neither. At the same time, dismissing public fascination would be a mistake. The intense interest in Hormuz Island reveals a genuine curiosity about Earth's hidden processes. The challenge lies in channeling that curiosity toward understanding rather than sensationalism. Conclusion. Iran's so-called blood rain is not a supernatural event, nor is it a sign of environmental catastrophe. It is a visually striking interaction between rainwater and iron-rich soil on one of the world's most geologically diverse islands. Hormuz Island doesn't bleed, reveals its mineral heart. What makes the event remarkable is not mystery, but geology. And perhaps the real lesson is this: nature doesn't need myths to be. The truth, when understood, is often just as powerful.